Hello guys, my name is Pino. In this video, we go through the following question, which is on arithmetic sequence, where we have 2k minus 7 as our first term and k plus 8 as our second term, and also 2k minus 1 as our third term. And for the arithmetic sequence, we have Tn is equals to a plus n minus 1 multiplied by the common difference d. And the common difference for an arithmetic sequence is d is equals to term number 2 minus term number 1, and this is also equals to, so the d for an arithmetic sequence is also equals to term number 3 minus term number 2. So let's determine first on the left hand side. Term number 2 is equals to k plus 8 minus term number 1, which is equals to 2k minus 7, and our d will be equals to k plus 8, and we distribute the negative sign, so we have negative 2k, and the negative multiplied by negative 7 will be equals to positive 7, and our d will be equals to, we have that k minus 2k, which will be equals to negative k, and also the 8 plus the 7 will be equals to positive 15. So this will be equals to positive 15. On the other side, d will be equals to, term number 3 is equals to 2k minus 1 minus term number 2, which is equals to k plus 8. So our d will be equals to 2k minus 1, and we distribute the negative sign inside the parentheses, so we have negative k and minus 8, and from here our d will be equals to, we have the 2k minus k, which will be equals to positive k, and the negative 1 minus 8 will be equals to negative, okay, this will be equals to negative 9. So now, since the d's are equal for an arithmetic sequence, our d will be equals to d, where the other d is equals to negative k plus 15, and the other d is equals to k minus 9. So now we solve for k. So we take that positive k to the left, and it will change sign to negative k, and you already have the negative k. We move the positive 15 from the left to the right, and it will change sign to negative 15, and negative k minus k will be equal to negative 2k, which will be equals to negative 9 minus 15, which is equal to negative 24. We divide both sides of the equation by negative 2, and the negative 2 on the left hand side will divide to 1, such that our k will be equal to negative 24 divided by negative 2, which is equal to positive 12. So we have k as equals to 12. So now we determine the numerical value of the first, the second, and the third term. We have term number 1, which is equals to 2k, but our k is equals to 12 minus 7, and this is equals to, but let's determine term number 2, which will be equals to 12 in the place of the k plus 8, and for term number 3, we have 2 multiplied by 12 in the place of the k minus 1. For term number 1, 2 multiplied by 12 will be equals to 24, minus 7 will be equals to positive 17, and 12 plus 8 is equals to 20, and 2 multiplied by 12 is equals to 24, minus 1 is equals to 23. So we have our a, the first term, is equals to 17, and the first difference, our common difference, d, is equals to term number 2 minus term number 1. So our d will be equals to term number 2, which is equals to 20, minus term number 1, which is equals to 17. So 20 minus 17 is equals to 3. So our difference is equals to 3. We substitute into our Tn formula, where the Tn will be equals to a. In the place of the a, we have the 17 as our first term, plus n minus 1 multiplied by the d, which is equals to 3. So our Tn will be equals to 17, and we distribute the positive 3 inside the parentheses, and we have 3n minus 3, and our Tn will be equals to, so we have that 17 minus 3, which will be equals to positive 14, plus the 3n. And now we have to determine the 15th term. So where there is an n, we are going to substitute. So where there is n, we substitute 15. So term number 15 will be equal to 14 plus 3 multiplied by 15 in the place of the n. And 3 multiplied by 15 will be equals to 45, and 45 plus that 14 will be equals to 59. So term number 15 is equals to 59. question 2.2.2, we calculate the sum of the first 30 even terms of the sequence. Remember that we determined that the first term, the second and the third were 17, 20, and 23. So we had the first term as equals to 17, and the third term is equals to 20, and the third term is equals to 23. 23 plus the common difference 3 is equals to 26, and 26 plus 3 is equals to 29, and 29 plus 3 is equals to 32. 32 plus 3 is equals to 35. So let's stop here and isolate the even terms. So we have that 20, the 26, and 32 as our even terms. From here, let's determine the common difference. We have the common difference 26 minus 20 will be equals to 6, and 32 minus 26 is equals to 6. So we have Sn, the sum to n terms is equals to n divided by 2 into 2a plus n minus 1 multiplied by the d, and this formula is available in the formula sheet. And we have the sum to 30 terms is equals to 30 in the place of the n divided by 2 into 2 multiplied by our first term is equals to the 20 plus the n, which is 30. So our n will be equals to 30, and we minus 1 from the 30, and the common difference in this case is the 6, the common difference between the even terms. So as 30 will be equals to so in the place of the d, I was supposed to substitute the 6. So the sum to 30 terms will be equal to 3,210.